Precalculus 1.2 functions. What should you learn? Decide whether a relation between two variables represents a function. So we're going to learn about functions. Use function notation to evaluate functions. We're going to evaluate some functions. Find domains of functions. Use functions to model real-life problems. And we're going to evaluate some difference quotients. So that's like the application of functions that you'll do a lot in calculus. Since we're in pre-calculus, it's helpful. So first, a function is just any relation, and a relation is just like any collection of anything that relates to values, two numbers, two values. That's all a relation is. It just relates to things. So functions, any relation where all the domain values are unique. That's it. So it's just a relation where all domain values, which is in most cases the x's, are unique. So no repeats. Now, only for the x values. That's supposed to say repeats. So it's only for the x values, all right? I don't want two of the same x's. It's all that's saying. So that's a function. You get any relation, like all these guys are relations, right? They're relating this guy to that guy, this guy to that guy. They're relating these x's to these y's. That's relating these x's to these y's. Anytime the x's are all different, that's a function. We don't care at all about the y's. Like here, we have red triangle to red spot, yellow rectangle to yellow spot, green concave hexagon to green spot, and then red rectangle to red spot again. All I care about is these guys. These are all different. So this is a function. Done. Now look over here. 1 goes to A, 2 goes to D, 3 goes to B, 3 goes to C. This is the problem, right? This is not a function. That 3 is 2 timing on B, right? Like that 3 goes 2 different spots. We don't want that. So not a function. Right? We want all the x values to be unique. If I made this like a point, this would be 1 in A, 2 in B, 3 in B, and then 3 in C. Right? And that's the problem right there. The 2 3's on the x. Now keep in mind, I don't care about the y's at all, right? See, there's 2 b's here, doesn't matter. It had like 2 things went to the y right there, doesn't matter. It's all about the x. So this guy's not a function. So if I was doing these two here, all you do is want to check the x values. Right here, there's 2 4's, not a function. And the last one here, 1 2 3, function. If you notice, I didn't even check the y's. The y's are all the same. Who cares? If I'm trying to decide if it's a function or not, all you're doing is checking the x's. So that's a function. Some characteristics of functions. Each element of A must be matched to an element of B. That's the kind of thing we're saying here, right? Every A has to go to a B. It's a function. Okay, A can't. So you might say, like, well, the blue doesn't have anybody. All we care about is the domain, right? These all have to go somewhere here. You can't have one by. If you had like a number by itself here, like 4, and it went nowhere, would not be a function. Some elements may or not match to elements in A, like you see here. Right now, they're not all used. 2 remote elements of A must be matched to the same element of B. That's what we're doing here. Right? See how they both went to the red there. That's fine. All we care about is the x. Element of A domain cannot be matched with 2 different elements of B. That's what they're saying here, right? So you can't have this guy go to 2 things there. So that's probably a longer way of saying the thing I said earlier. Okay, how about independent and dependent variables? An independent variable, so if you think about like an equation, independent variable is the one you generally plug into. That's the independent variable. That's the independent variable. The one you're like plugging into, the x values, generally considered the independent variable. If you're gonna plug numbers into it, and that changes, right? The dependent variable is the one that you get the answer from. Right, I plug in 2, I times it by some value here, I add some number there, I get the y value. That's a dependent variable. It depends on what happens here. So that's kind of the idea. The one that's like an equal sign, that's a dependent variable because it matters what happens when you plug the stuff in. So that's an independent and dependent variable. So the thing you plug in is an independent, the thing you get out is a dependent. Now, how do we test if something's a function algebraically? That's the next step. How do we tell if something's a function using algebra? So general rule here is this. All we're going to do is this. Here's our steps. 1, solve for y. And then 2, if, well, solve for y, if we were trying to find the equation represents y as a function of x. So in that case, we're solving for y. If you get a plus and minus x, that's not a function. If you just get x, then it is a function. That's it. That's all it is. You want to solve for y. If you get a plus and minus, then it's not a function, because that means you have 2 x's for every y, which is, again, the no-no, right? You can't have that. If you don't get that, then it's a function. So that's all it is. So if I'm trying to determine if this is a function of y if this is a function of y as a function of x, all you have to do is solve for y. So like here, let's subtract x squared. I get negative y squared equals 16 minus x squared. Let's divide by that negative 1. And honestly, I'm going to go back. I'm not even going to erase. We're going to keep this up there. I want to get y by itself. I'm just going to add y squared to both sides. It's just easier. So I get x squared equals 16 plus y squared. Let's subtract that 16. I get x squared minus 16 equals y squared. I want to get y by itself, so we're going to square root both sides. Now what happens when you square root something? You get a plus and minus. So we get plus and minus square root of x squared minus 16 equals y. Now please, we'll talk about this later, but don't give me x minus 4. That's not the way this works, right? These are separate entities. This guy is not the same as this guy. That's not the way math works. So don't do that. We just have this. And notice you have a plus and minus, so this is not a function. The next one, same idea. We're going to solve for y. So let's add that 4x squared to both sides. And I get y equals 36 plus 4x squared. Technically, I should put the x squared in front, but it doesn't matter. No plus and minus, right? I just solved, I'd added, I didn't have to square root anything. This is a function. So that's how you tell. If I give you an equation and say, hey, is this a function of y? Is this y as a function of x? All you have to do is solve for y. If you get a plus and minus, that means you have 2 x's for every y, not a function. If you don't get a plus and minus, you're golden. It's a function. Okay, how about function notation? So a lot of times when you have an equation, it's easier to reference as a function. So like here we have y equals 1 minus x squared. We could also write this as f of x equals 1 minus x squared. That gives a function, or h of x, or j of x. That's all that is. So it's the same idea, right? The input is the independent variable. That's the input. That's what you're plugging into. And then f of x, the y, is the output, also known as the dependent variable. That's its function notation. This is another way of writing an equation. Right? And the general idea, whatever you have in here gets plugged in for the x over there. Right? So you can get like 1 minus blah, blah, blah squared. Right? Whatever is in here, you just substitute in for the x. Or no matter how many x's there are, you just plug them in for all of them. And then you simplify it. And there you go. So let's do a quick example here. I have f(x) equals 2x minus 3. We want to figure out what f of 1 is. So f of 1, right? This function here is just this. This is all this function is. Right? Whatever's inside my x, I plug into there. I substitute into there. So f of 1 is just going to be 2 times 1 minus 3, which is 2 minus 3, which is negative 1. Same thing for the next one, f of negative 3, right? Just plug into the function. 2 times negative 3 minus 3. Simplify, I get negative 6 minus 3, so I get negative 9. And by the way, let me write this. You don't have to do this, but let me bring that down. This is just like a sentence. You're saying, hey, when I plug in negative 3, I get negative 9. That's all it is. So many times I see people like divide by negative 3. I'm like, what are you doing? Why do you make my life why are you making me so upset for? Right? All this means it's a sentence. Hey, when I plugged in negative 3, I got negative 9. So your answer is negative 9. Let's talk about this one. This one's way more confusing for people, right? F of x minus 1. It's the exact same thing though. F is this function here, right? You do 2 times something minus 3. What's it something? In this case, x minus 1. That's what you substitute in. Then we're going to distribute 2x minus 2 minus 3. Add up like terms. 2x minus 5. And that's our answer. Right? If I want to rewrite it like nicely, right? All this is saying is when I substitute in x minus 1 for x, when that's my independent variable, I get this as my answer. That's all it is. How do we do a piecewise function? So remember, a piecewise function is when you have a function that's broken up into pieces, essentially. So look at this one. F of x equals 2x plus 5 when x is less than 0. Right? That's the key here. This right here is the key. And f of x equals 2 minus x squared when x is greater than 0. So all we're going to do is the exact same thing. So f of negative 2. First thing you do is check which one does it fit under. Is negative 2 less than 0 or greater than 0? Negative 2 is less than 0. So we're going to use the top one here. So negative 4 plus 5 is 1. And there you go. That's it. F of 0. Well, it is a 0, right? In that case, look for the equal to sign, right? Because that could be less than or equal to 0. So we're going to plug it into the top one again. So you get 5. F of 1. F of 1 is actually greater than 0. So we're going to plug it into the bottom one. I get 2 minus 1, which is 1. And that's how you evaluate with the piecewise function, right? You just look at here and see which one do you plug into. You don't plug into all of them. It should just be plugged into one of them. And then how do you tell which one? Look at the key right here. Okay. This is about domain of a function. Domain of functions are the set of values that you're allowed to substitute in. That's the key. What can I plug in is always what I ask myself. Now we're going to start slow here, and over the school year we'll add up more and more domains, but we're starting with the basics. So again, so what are you allowed to plug in? I always think of the issues. Think of what you can't plug in. Think of numbers you can't sub in. So polynomial is the first one, right? There's actually no numbers. There's no issues here. You can plug in anything you want. So this is domain here is always going to be all real numbers. No matter what real number you plug in, you're going to be fine. Also known as negative infinity, positive infinity. We'll talk more about that later. Now, here's where it really starts, and then you probably see what I mean by allowed to, or think of numbers you can't plug in. Can't plug in. In a fraction, you can't divide by 0. So my domain here is anything that's not the bottom equal to 0. Right, that's your domain. As long as the bottom doesn't equal 0, you're good. So the domain here is anything that makes the bottom equal 0. So like, for example, if I gave you 2 over x minus 4, domain here would be, get the bottom, set it not equal to 0, because you can't divide by 0, then you just solve it. X does not equal 4. It's a domain. Right, domain's everything except for you can't be 4, because 4 makes this thing bad. That's what domain is. What can you not plug in? Or what are you allowed to plug in? No way to say that. So in a fraction, the bottom cannot equal 0. What happens in a square root? In a square root, you can't plug in negative numbers. So my domain here is that guy has to be greater than or equal to 0. Right? You can plug in 0. 0 is okay. You can plug in numbers bigger than 0. You can't have any negative numbers. So for example, if we did, what's the domain of this guy? Right, I was like, hey, what's the domain of this guy right here? You would go, okay, well, the thing underneath the square root has to be greater than or equal to 0. Then you just solve it. And there's your domain. Right, those are numbers you're allowed to plug in. Anything less than negative 2, you can't plug into this because you'll get a negative under the radical, and that's not a real number. So that's domain. It's all about what numbers you can plug in or allow. Now let's finish up with the difference quotient. Now, the difference quotient is big in calculus. It's a huge thing in calculus, and we're in pre-calculus. But for now, it's just a good way to practice how well we understand our function notation. That's all it is. So it's just this ratio that we're going to use a ton. That'll make way more sense in calculus. But for now, it's how well do you know functions? How well could you simplify a function? And this is a difference quotient. This guy right here. That's all it is. It's just that ratio. That's all the difference quotient is. So all we want to do is, can we evaluate this function using the difference quotient? Now the key thing here is h's are just h. All I want you to do is, okay, wherever you see an f of x, plug in your f of x. Whenever you see an f of x plus h, evaluate that with your f of x, and then see what you get. That's all it is. You're not going to plug in anything for h. H is just h. It's going to stay h. So let's get to it. So here's the idea. So let me start this. Here's my h, right? Because h is not going to change. let's look at one part at a time. So how about f of x right there? Well, f of x is just a function. What's our f of x? 4x plus 7. So this guy right here is going to be 4x plus 7. That's all it's going to be. I put in parentheses because there's a negative out here. That negative is still going to be there. And I don't want people, a lot of people, if you don't put the parentheses, people just think it's a negative 4x plus 7. That's wrong. Right? You have to distribute the negative. So I like to put in parentheses. Now, here's the key to the difference quotient. How do I evaluate this guy? What is f of x plus h? Now, hopefully, you understood the thing we went over in class before. F of x by itself is just this guy where you plug in stuff for x. So this is just 4 times something plus 7, right? And all we're going to do is plug in x. That 7 looks funky. There we go. Right, and all we do is plug in x. Whatever's in here, you plug in there. It's the exact same thing for f of x plus h. It's 4 times something plus 7, but that something is x plus. So we're going to plug that into here, and that is f of x plus. That's f of x plus h is that. So all this, all right, all we're doing is plugging x plus h into the x there. So it's going to be 4 times x plus h plus 7. So let's write that over here. 4 times x plus h plus 7. Sorry, put a little, jumped the gun a little bit, like that, right? And that's the difference quotient. All we gotta do now is simplify it. So that's the fun part, right? We distribute this 4 to both of them, so I get 4x plus 4h plus 7, right? That's all this part. Then we distribute the negative here, so you get minus 4x minus 7. This is all the same, right? So all I did was distribute the top, distribute the negative, left the bottom alone. And then honestly, this is my real favorite part. Stuff cancels out. Look here. The 7 and the negative 7 cancel out. The 4x and the negative 4x cancel out. And you're left with 4h over h. And in this case, the h's cancel. And I just get 4. So that's how you simplify a difference quotient. It's just looking at this difference quotient here and just understanding how functions work and then substituting it in. If you can do that, you can do the difference quotient. And that's the lesson.